Hi Pre-Calc, we're going to work on 3.4, which is exponential and logarithmic equations. I'm going to start with the exponential equations. Okay, so for the exponential equations, how you solve them is you solve them with a logarithm. So it's always, if you have exponentials, you solve them with logs. If you have logs, you solve them with exponentials, okay? So you want to start by isolating the exponential. So I'm going to divide off the 4. Okay, and now since this is base e, the easiest way to solve this is for me to pick a logarithm with the same base. Let me write this a little bit. So I'm now applying a logarithm to both sides. And if you remember the rules we just went over, that means that I can bring the x down in front. And also, if you remember, the ln of e is 1. So this is what we would call the exact answer. This is what we would call the exact answer. And if I put it in my calculator, I could approximate this. Now let me see, when we do your homework, they want 3 decimal places. Okay, so let me do that with you. ln of 91 divided by 4. All right, so the 3 decimal places, that's 3.125. Alright, so I'll do more with you, but again, the general idea is isolate the exponential if you can. Once it's isolated, apply some logarithm to both sides, and then that will allow you to bring the exponent from up in the air down to the ground, and then either you're giving the exact answer or the approximate answer. Your book is asking for the approximate answer, so I'm gonna end up here at the approximate when I do these. Okay, let's try this one. So if you remember what I just did, I'm going to isolate first. Let's see, if we take away 8, that's going to be 18. Now, there's 2 ways to do this. One way to do this is to do, since this is base 5, is to do log base 5 to this exponential function. So one way to do this is to apply a log base 5 because this and this match, so they'll cancel out nicely. I use that log property we just learned where you can bring the exponent down in front. Now since this matches, this is going to end up being a 1. Right, if you think about log 5 to the what equals to 5, it has to be 5 to the 1 equals to 5. So this is what we would call the exact answer. If your calculator can do base 5, then you can put it straight in. Mine cannot. My calculator cannot do base 5, so that's why I taught you the change of base formula. So if I do the change of base formula, I now can solve this. ln of 18 close parenthesis divided by ln of 5 close. Okay, so x is about 1.796. 1.796. Okay. Now the other way to do it is to not worry that the bases are matching so that this goes to a 1. The other way to do it is that you could just always use a common log or an ln. So you could have started, I just want to show you both ways because some people who don't really, they find this section confusing. You can just always use an ln. It will always work. Okay, so I just show you that. So just so you can always just use this technique if you just sort of need to get through it. If I just put an ln on both sides, you'll notice that this will also work, and you may like it better. Alright, so ln on both sides, bring the x down. Now this won't go away, but I can divide it off to the other side. Okay, so now if you notice, I'm matching here at this stage. These are the same, and then if I put in the calculator, I'll get that. Alright, so you don't have to match the base unless you want to. It's sort of a nice technique. If you're going to go right to the exact answer, it'll get you there, you know, in the same amount of steps. It's when you start estimating and you need to change a base. Okay, gang, so whichever way you do that one, you're going to get to the same answer. And again, if this is a bit confusing to you, you can do an ln on every single problem to both sides, every single exponential, and you can get that to work. Okay, so if you want to be fancy with the bases, this one you can't really, you could pick one side or the other, right? You're not going to be able to kick out both. So I'll just go with the generic ln on this one to both sides. I can't isolate anything because there's exponentials on both sides. Alright, now I'm going to bring the exponents down on both sides. Alright, now I have to get the x's on the same side. So, oh, well this is ln of e over here, so let's just go ahead and get rid of that while we're at it. ln of e equals to 1. Alright, so for this guy, you know, we can just distribute this in, so x ln 2 plus 2 ln 2. Now let's get the x's on both sides, so on the same side. So let's move this guy over. And let's move this guy over this way. That'd be -1 on this side. So I moved this term to the left. I moved the 1 to the right. That's what I did here. Because now I can factor out the x's. I can divide that off. Let's see what else I got. Okay, so now I'm just going to approximate that. You could have done the algebra a little bit differently than I did, but we'll both come with the same answer. Alright, I'm just going to plug this in. So -1 plus 2 ln 2. I'm just going to hit equal here, and then I'm going to divide it by parentheses, because I want to divide it by all of this. 1 minus ln 2. I got a double parenthesis on that. Okay, so this is going to be about, I hit something, I don't know what I hit. Let me try again. -1 plus 2 ln 2 equal sign divided by all of 1 minus ln 2, close the ln, close the bottom. Alright, let me not touch it again, I'll just write it over here. So this is about 1.259. That's the approximation on that. 1.259. Okay. Alright, so that's this one. This one was a pretty fancy one that we just did. Okay, this one also is going to be a bit fancy. This is like a pseudo-quadratic. So what you're going to do is you're going to factor this. Because e to the x times e to the x is e to the 2x. And let's see, it's got to add to a 6 negative. Okay, so it's got to be -3, -2. Alright, now you're going to use the zero product rule, meaning you're going to set each of these equal to 0. You're going to isolate the e to the x. So you're going to move the constant to the other side. Okay, so all I did there is I moved the constant over. Alright, now you're ready for the ln step. So now you're going to do the ln to both sides. You're going to take the ln of both sides. right? Because that's what allows you to bring the x down. ln of e is 1. Okay, that's the exact answer. I'll do the calculator in a minute on it. Same thing here. You bring the x down. Oh, I brought it down. ln of e is 1. Okay, let me just give you the approximations because those are the exact. So ln of 3, that is 1.099. That's the approximation on this guy. And ln of 2 is 0.693. That is the approximation on that guy. Okay, so this one we factored. Okay, I'm already at 11 minutes. I think I'm going to stop it on this one and catch you in another video. Catch you. Bye-bye.